So this is the 2016 Junior Cert High Level Paper 2, and we're looking at question number 9. A shape is made by placing a small cube on top of a larger one, as shown. The cubes have edges of length 1 unit and 2 units. Part A says find the total surface area of this shape. Okay, so we know that the bigger cube has sides of 2 and the smaller cube has sides of 1. Okay, so the total surface area of the shape, well, if we imagine that the top of this cube here can be combined with the top of this surface area, the two pink surface areas there is just going to be the same as one side of the big cube. So in terms of the big cube you've got one side, so for the big cube one side is equal to 2 by 2 units, which is 4. So that's for one of these sides down here, the side, the bottom. They're all the same, so there's 4. So if we now imagine that there's the bottom, the two sides, the front and the back, and then also this one on top made up by the two pink parts, well, that's 6 sides. So 6 sides would be equal to the 4 times 6, which is 24 units squared. So that's the surface area of the big cube on the bottom, including this pink bit here. So all that's left then is the faces that are exposed of the small cube on top. So you've got the front here, the side, the back around here, and then the other side here. The bottom can't be seen because it's attached to the big cube, and the top we've already accounted for. So for the small cube, we're looking at, for one side, it's going to be 1 times 1. One of the faces will be 1 by 1, which is 1. Well, we have 4 sides to account for, so it's going to be 4 by 1, which is obviously 4 units squared. So then the total surface area would be the 24 and the 4, so total would be 24 plus 4, which is 28 units squared. So that's the surface area of the shape. Okay, part B, the line segment AB is a diagonal of the base of the shape as shown. Find the length of AB. So these straight brackets here mean the length. So we have to find the length of AB and give your answer in surd form. So leave it with the root signs in other words. Okay, so if we can, best way to do this is to have a look at this triangle here. If you can imagine this triangle here, if you can imagine the true shape of that triangle, in other words, if you came in on top here and looked down on that triangle, what would it look like? Well, it would look like this. Okay, that's A, that's B, there's the diagonal, AB. Now, you know this is a right angle because this corner in here is the corner of a square because it's part of the cube. And you know that this side here is 2 and this side here is 2. You know that from the question. So you're looking for the length AB, which we can call x. Well, this is Pythagoras Theorem, and Pythagoras Theorem states that the square on the hypotenuse, which is x squared, is equal to the sum of the squares in the other two sides. So if this is c, in other words, c squared is equal to a squared plus b squared. So x squared is equal to 2 squared plus another 2 squared. So that tells us that x squared is equal to 4 plus 4. So x squared is 8. And if x squared is 8, well then x is the square root of 8. And when you put the square root of 8 in your calculator, it simplifies it down to 2 root 2. Both these answers here would get you full marks, though, root 8 or 2 root 2. But that's the answer in surd form. Surd form. Okay, well, the right angle triangle ABC, we can see that here, is constructed inside this shape as shown. Part 2 says find the length of BC and give your answer in surd form. Okay, well, we've just found the length of AB here to be root 8. And we're looking for BC, this diagonal here. So if we, again, imagine coming around to the side here and looking in perpendicular to this shape at the true length of it, the true shape of it rather. The triangle would look something like this. This is just a sketch. So if this is the point C, this is the point A, and this is the point B. Now we know this would be a right angle because this line coming up is at 90 degrees to the base. So we know AB is root 8. Now this line here, CA, well that's going to be 2 up to this quarter and then another 1 that was given in the question. So that leaves us with distance of 3 there. And we're looking for BC, this length here, which we can call y this time. So again, it's Pythagoras, and what Pythagoras says is that the square on the hypotenuse, y squared, will be equal to the other side squared, 3 squared, plus root 8 squared. So when we work these out, that gives us 9 plus root 8 squared. You can do all this in your calculator, but root 8 squared is just 8. So it tells us that y squared is equal to 17. Well, that means that y is root 17. And again, that's our answer in surd form. Root 17 doesn't simplify in your calculator, so that's the final answer there. Okay, part 3 says, just leave the diagram in view, find the length of the part of the line BC that is inside the larger cube. So part of the line BC will be inside the larger cube. Okay, so the part of the line BC that would be inside the cube would be, if you can imagine from this point here, if you drew a line across until you hit line BC like that. In other words, from here, if you drew a line across until you hit the line BC there, we want to know then the length of the part of the line BC that's inside the larger cube. In other words, we want to know this length here, which on the 3D diagram would be this one there. Okay, so that's what we're really looking for. So, how do we work this out? Well, if we look, I'm going to redraw this down here now. Well, actually I won't, I'll just do it up here. So we know that this length up here is 3. However, we know that this part here is, distance of 1 here, and we have a distance of 2 here. So if you have a distance of 1 there and a distance of 2 there, well, if we look at this small triangle here, the small triangle here, this one, contains this angle, and so does the big triangle here contain that angle. Okay, and we can say here, if we drew this line straight across, that this is 90 degrees. So this angle and this angle here are obviously the same, and because this line here is parallel to this one, we can then say that the angle here at this point must be equal to the angle here at this point. So therefore the small triangle up here and the big triangle are similar, because there are three angles in each of them are the same. So that means that if the two triangles are similar, it means their sides are in proportion. So if we know that the length BC from our previous question BC is root 17. We know the length of BC is root 17, this whole length here. Well, it will be in the same proportion, the green part rather, would be in the same proportion to BC as this length here would be in proportion to AC. So what we can say is that this section here is 2/3 of the whole line, because it's up to 2, but the whole length is 3. So this section here is 2/3. Well, then the green part here should be 2/3 of BC also, because it's in proportion. So we can say that the answer then will be 2/3 of the root 17. And when we put that in our calculator, 2/3 of root 17, that just simplifies to 2 root 17 over 3. So that's the length of the green section of the line. And that's the end of question 9.